All right, we'll get started here. We got some newcomers. Glad to have you here for the show. And let's see. Let our eyes adjust here a little bit. My name is Warren, and we have Anderson Fernandez on one of the on the YouTube back there. Killian is running on the star ball, and Rebecca is the laser. Okay, so we got the team back there. Also, we on the YouTube internet now or not? We are. Okay. There are, for those of you that are listening on the internet, glad to have you here and to listen to it. You'll be able to follow along as I point out the different constellations and the stars and what's up there and what's happening in the next month. Plus, if you have a question, and this applies to those on the internet and anyone in here, I'm always comfortable if you have a question, I want you to call it out to me right then. Now, in a little bit, we're going to turn out the lights and it's going to get dark. And so you have two choices. You can raise your hand, and I won't see it. Or you can just call out, and make sure you call out loud enough I can hear you over the machines or whatever else is going on. For those on the internet, on YouTube, if you will type in your question down in the, reply box? Live chat box, okay. And either Killian or Rebecca or Anderson, when they see that, they will read it and then let me know here as far as what your question is, and we will answer the best we can. So let's go ahead and get started, and we'll see what we have for next month. For those who are not familiar, here is our website. It is www.starsatnight.org, and when you click on that, this is the initial screen that you're going to get up after you've typed in there. And so then the next thing you want to look for is over on the menu, you want to look for the word blog, B-L-O-G, right there. And when you click on that, you will get a list of different ones. I'm doing the astronomer. Let's see, Jackie is doing educational, Anderson's doing director, Fred's doing that, and webmaster is Anderson. But anyway, when you click on the astronomer's blog, then you will see a list of what has been loaded in. And I just put this up a little while ago and copied it out, and this is the current list at the present time. And you'll see here's about direct, prograde, retrograde motion, and then here is a list of these constellations we're going to talk about this evening in preparation for January, and then there's the list, and it goes on down. There's 4 pages of information that's on the blog. Now, a quick review, because in December, here is tonight, Saturday the 20th, and I just wanted to point out real quick as a review, we're not going to talk about it much more. Here was the constellation Auriga, that's tonight. However, I think it'll be a little difficult to see because of the cloud cover. And also, as you can tell, we're doing our January night sky presentation. Here is Auriga, the chariot driver, and I want to show you something as far as how to find the North Star, the North Pole Star, Polaris, using the chariot driver, Auriga. What we want to look for is when you go out on, if you were out at tonight and it was clear, you'd look around to find the brightest star that you could see. And it would be early in the evening. It's going to be Capella, which happens to be the 6th brightest star in the night sky. And when you do, also to identify, you'll look for these three faint little stars here. These are called the kids, K-I-D-S, as far as lambs or kids. And then you know that you're at the correct one. Go over, and you're going to find this star right here, Menkalinen. We're going to find this one, Delta, and this one, Theta. And what we'll do, or what you would do, would want you to measure the angle from Theta to Delta with your hand. How do you do that? Well, let's take a look. You can measure angles in the sky using your hand, either hand, at arm's length. As you can see, your little pinky at arm's length would be approximately 1 degree across. Now, they don't have it on the slide, but your thumb would be about 2 degrees. Then the middle three fingers 5, a fist 10, hook 'em horns about 15, and then from fingertip to fingertip about 25. So in this case, you're going to have to measure more than likely with the full from tip of your thumb to the tip of your little finger. Now, what you want to do is this one here, Delta, is going to be your anchor point, and you're going to swing then from the other finger all the way around, come up, and then let that be the anchor, swing again, and you will wind up at Polaris. We'll demonstrate that in just a little while when we get on the star ball. But these three are virtually, for us with our eye, they are perfectly in line, and they point, if you will, directly toward Polaris. So twice this angle gets you to Polaris. Let's look and see what else was on there. Tomorrow night, the 21st, is the winter solstice, when the sun is at southernmost declination and our winter begins. Here is Earth as it is tilted. The direct sun is right over the southern Tropic of Capricorn. As you can see, for us up in the northern hemisphere is when we are leaning away, tilted away from the sun. And the southern hemisphere is, if you will, tilted or leaning toward the sun. And see here, here's Antarctica, the South Pole. It's in full 24-hour sunlight. North Pole is in full 24-hour nighttime darkness. The other thing we had on here was that on that Sunday night is going to be a new moon. Here it is here, and the lunation number. We reviewed that last month, and that's what that refers to. The other thing is on the sunset on Monday night is the beautiful constellation of Orion. Last month we talked a lot about Orion. Just real quick, it is, you see it straddles the equator, so this would be called an equatorial constellation. And we should have no problem identifying Orion in the night sky. It's going to be, we'll use it this evening as we talk about for the other constellations for January, and use it in different ways as a pointer for us. The other thing is at the Little Dipper. Here's Polaris, the end of the handle. Come over by the pot and out at Kochab, right there, that little place is where the Earthside's meteor shower will be seem to come out of, the radiant point. And then we had down below Orion was the rabbit or the hare, Lepus, right down here. Here's the bottom of Orion's feet, if you will, his feet. And we talked about that, of course. Then we had the close moon, the perigee moon. Remember that we talked that the orbit of the moon is elliptical. It is a circle, but it's not a perfect one radius circle. And so on that night we will be closer, or the moon will be closer to Earth. And then also the last one was a constellation called Mensa. the table, the mountain, and it's way down to the south, and down below the large Magellanic Cloud. That's what we talked about. And then here is the small Magellanic Cloud. The two of these are constellations. There's a total of 6 galaxies. These 6 galaxies are the ones we can see with our naked eye. From where we are up here in Texas, we cannot see these 2, but we can see 4 of them. All right, so, and then the last was the quarter moon, and then the constellation Columba. Here's the quarter moon, which will be on Sunday a week, the 28th. And then the last one is also that same evening is the constellation Columba, the dove, right here. Okay, now let's get on with our January calendar and what's coming up in the first week. Here we have right here. You notice on Friday we're going to have the opportunity to see the constellation of Canis Major. And each time when to look at it, the best time to see it is at midnight. But we have to remember that midnight starts, and when it at 12 p.m. or 12 a.m., excuse me, when that is, that's on the evening of the previous night. So that's why we want to go out on Friday the 2nd. And if you'll notice, the chart says this is January the 3rd. So you always go out the evening prior to the date. And in this constellation of Canis Major, we're going to have 5 stars and 2 star clusters that we have here. Notice up here on its upper right to the east of it, we have here is a portion of Orion. Can you see where the belt is? Notice how the belt is, we can use the belt to point down to the south west of it, and we will see southeast of it, excuse me, and we will then look for that bright star, and Sirius there is the brightest star in the night sky. Here is what page 2 that's on the website, and it has the information, different things there. And here's about those 5 stars. And so here's what we'll do. The first one right here, this is the star of Mersam, right there. And then second is Sirius. The significant thing of Sirius is that it is the brightest, and one of the reasons it is the brightest is because of some characteristics of stars that help determine how bright it looks in the sky. So what would be one of the things that you could think of that has a factor on how bright a star is in the sky? Pardon? Size, all right. It is a large star. It is bigger than our sun. And that information is on there. What's another thing? Color, all right. It is a hot star. It is a hot white, very hot. There's a third thing. Distance. This, for us, up here where we are in Texas, this will be the closest star you will see in the night sky. It actually comes out as the 3rd closest star for us because down in the southern hemisphere, Alpha and Beta Centaurus are closer, but we can't see them unless we went down to south of San Antonio on down toward the valley, then we could. So this one is 9 light years away. If you went out tonight, or on January the 3rd, and you look up in the sky and you identify here, you identify Sirius, you would see the light that left that star approximately in 2000, what would it be? 5, 2005, 9 years for that light to travel to get here. Okay. Our next one is down here is Atara, and we'll point that out. Here he is, the back of his body, then for the back 2 legs. The next one is Wiesen, or Wiesen, depending on how you like to pronounce your W, right there. And then number 5, Aludra. Now, what did we say? What did I say about Sirius, its distance? Okay, it's close, and it will be the closest star we will see in our sky up here in this part of Texas, right? Aludra is going to be the farthest one that you will see of the 100 brightest star magnitudes. It is a little over 3,000 light years away. So what makes the big dog interesting is that when you look at it, we have Sirius, the closest star, and we have Aludra, the farthest star. So we're able to look at there. So let's see. If we subtract 3,200 years from 2014, we're looking at about, give me my math, let me see, about 800 BC. Thereabouts. No, 1800 BC. Now, we also have a Messier object right here, and here it is right there, M41, right in here. Identified as that. And we have one more on our sheet. Here it is here, in Messier 41. It's these ones with a little star, if you want to call that, on it, because they are closer to us than the background stars there, Messier 41. So that's what we have. The other thing is we have a Caldwell one right there, Caldwell 84, 64, NGC 23. Here it is. And there we have, there's that little cluster right there, way deep sky. By the way, the red glow there on the picture, that would be a nebula. Nebula is Latin for cloud, and we will see later other pictures. The cloud can be either gas, like it looks like this, because we can see through it, or it may be solid material, dark material, and so that's what nebula means. Well, there's one more thing about Canis Major. It's got a lot for us. In here, it's hard for you to read, but in this constellation is VY Canis Major, right there. Currently, this is the largest star in our galaxy that we are aware of. And here is a relative picture of it. Here it is here. Its volume, it would hold a little over 13 billion of our suns to fit in there. To give you an idea, our sun is on that slide. Can you see it? Right there. Not the circle, but the dot. That would be in relative size what our sun would be in relation to this star. Realizing that our sun, we could put 1 million of our Earth inside our sun. Makes you feel real important. All right, let's go ahead. That was week 1. Let's look at week number 2 here. And the first thing that comes up is something called perihelion. Perihelion. You can read there, Earth closest 2015. In a way, that's kind of a trick question if you ask someone. There is, again, in our for our Earth orbit around the sun, this slide is greatly exaggerated. And again, it's a full circle, of course. but again, it's not a circle with a constant radius. There is a time of the year, in this case, January the 4th, when we are going to be closer to the sun, and then there's going to be 6 months later, in this case, July the 6th of this next year, when we are going to be farthest away from it. However, if you ask someone and say that there's going to be 2 points along our orbit, one in which we are the closest and one in which we are the farthest, and it happens in January and it happens in July each year, ask the person which one do they think that we are the closest to the sun. The majority of people are going to say, well, it has to be July because that's our summer. And that's not correct. The difference is because in July we are tilted away. Remember, we talked about that we're coming up here on our winter solstice. And what happens for the winter solstice for the northern hemisphere? Are we tilted toward the sun or away from the sun? We're tilted away. So even though Earth is closer, we are tilted away, so we don't get the heat that we would get if we were in the southern hemisphere. So there you see the difference. The next thing, and there's also, for those who need, there's the distances. The other thing is on that same Sunday night, we will have a full moon. The full moon is when it is on the opposite side of Earth from the sun. Now, notice there is no information or anything talking about an eclipse. And you would say, now, Warren, because the full moon is in line with the Earth and the sun, there should be an eclipse. Well, it's possible, just like it says on the slide, these are the possible times you can have an eclipse of the moon. However, the orbit of the moon in relation to Earth, it is tilted 5 degrees as we go around the sun. So there will be a time, in this case, when the moon comes around on the opposite side of us from the sun. It can be either above, the tilt could be above, or tilt could be below. So either place, if it's below or above, it will not come in contact, if you will, or go through the shadow of the Earth. That's why there is no eclipse in January. Then we have, as we continue on for our constellations, on Tuesday the 6th, we have Gemini and Manasseh. Let's take a look. Here we go. Now we're going to start connecting things for us as we go along. And remember earlier, we talked about Auriga, the chariot driver. And as you can see here we have Auriga, and then here is Gemini. Another very good helper for us in pointing. Look down here to the south of it and to the west of it. Here is the upper part of Orion. And so when you pick out the belt, and you look at the top of the belt for Betelgeuse and also for Bellatrix, you can see they just keep going up in a northeasterly direction as you come to Gemini, right here. We have in Gemini, as you can see, 3 stars. And here we go. Here's the second page. There's our 3 stars, the information about them. And the first one, Alpina, right down here, that's the foot of Pollux, one of the twins. That's its foot right here. And then number 2 is the head of Castor, the other twin. And then the head of Pollux, the twin here. The other thing we're going to have in there is an open cluster of FCA and NGC clusters.
Here it is, Messier 35, NGC 2168. We point out the M is a letter designating for a French astronomer back in the 1700s, Charles Messier. What he was looking for in the night sky was to find a comet. Now, what is a characteristic of a comet when you look for it in the sky? What does a comet look like that's different than a star? It's got a what? It's got a tail. Okay? That would be one thing we would want to look for. Now, we also have to remember this Messier is doing this in the 1700s, which means he is only doing this with technology that's barely 100 years old. Because Galileo, if you want to say discovered or put together the glass lens and created the telescope in the 1600s. So he's doing the best.
Now, what he's going to 35. And he just did them sequentially, 1 through 110, if I remember right. And 35 does not mean 35th largest, 35 biggest, 35 this. It's just the 35th one. So he would go off and look in other parts of the sky and come back, and he would come through and again, oh, wow, and he'd see this, and he'd get ready to record the address, and he'd see that this is still here, which means then that is not a comet. The reason he was trying to find a comet, because even today, if you were the first person in looking in the night sky and you were able to find a comet that had not been identified previously, you write down all the information, send it off to Paris, to the IAU, International Astronomical Union, and they check and cross-check, and they say, yes, you're the first one. You have the privilege of naming that comet after yourself. And so that's what he was trying to do. And since this did not move, that is not a comet, that is a cluster. And here we have the clusters of M35 and NGC 2158, that clusters here. Okay? Here's some more in the constellation here. Notice how creative the astronomers are in naming things. Eskimo Nebula. The Medusa. Remember me talking about earlier? Nebula, what does it mean in Latin? Cloud. And so here we have a giant gaseous cloud in the Milky Way that they can take a picture of here, the astronomers. All right, let's continue on. January the 6th. The other one was the constellation of Monoceros, which means Monoceros is Latin for one horn. So the unicorn. And we have here. Not a whole lot as far as you can see with stars that we have, but we do have here we have a cluster. Again, here it is. It's a Caldwell. This one right here. It's an open cluster. There's its address. And let's take a look. There it is. Caldwell 50. Notice there's your nebula. Here's some more. Now, Monoceros has a number of different items. Do you see this up at the top of the slide? This is a well-known object in the sky, in the night sky. And right here, we'll get a close-up, the Cone Nebula. We'll look at that in a little more detail. Here is the tip of it. Right there's the tip. You notice here is still nebula, and notice this is darker, so this is a little more solid than just a pure gas. And let's get in here. There it is. Now we're going to come down to this. What is that one called? The Fox-Fur Nebula. Well, let's see if we can figure out why it's called fox fur. What do you think? There you go. Like a fox's fur. Okay. So here they are together. There's the Cone Nebula, and here's the Fox-Fur Nebula right here. Now, what's we can also do is we'll start out, we can connect some stars, and we come up with another little fun thing. So let's draw the lines. And we have the Christmas tree cluster. Okay. And the star down here is S15 Monoceros, right there. There we have. Now, here you give you an idea of when Galileo did this. In 1610, on January the 7th, he sighted 3 of Jupiter's moons. There you go, Callisto, Europa, and Io on that night. And then also on Thursday, Mars enters the region of the sky that's designated for the constellation of Aquarius. That's on that Wednesday night. So let's go down to Friday. Friday, on January 9th, will be the latest sunrise of the year for us here at our latitude, right here, latest sunrise. Another thing we're going to see is an apogee moon, and we have a constellation to look at. So let's take a look. Here again is the orbit of our moon around the Earth, and we said this is the apogee, which means the moon at this time is going to be farther from Earth on that date, that night. There we have that. The other thing we talked about is there's going to be a constellation called Puppis, right here, Puppis, the stern. This is part of 3 constellations that we're going to be talking about. Right here, Puppis, Carina, Vela, and there's a couple more that we have. That used to be one giant constellation called Argo Navis, and that's the name of the mythical ship of, what was his name, the Argonaut? Jason the Argonaut. Anyway, they divided it up, and so here's this one here. And as you can see, as it indicates, we have 3 stars in here. So here they are. Here's the first one. It doesn't have a common name. It's just its designation, Pi Puppis. And here is Naos. And then up here is Tures. And we'll see. In being able to find it, it's going to be real easy, because look what's right here. What's this one? Canis Major. What's that star right there? Sirius. Okay, here's the big dog right here. We come on down to the others, and so we will use this, the backbone of the dog, to help point right to Puppis right here. We also have in there, again, we have also another cluster, M47, or NGC. This is another one that he found, and here it is here. Not a whole lot to it. You can see the rest of these are, we would say, background stars further away from us in our galaxy, in the Milky Way. Now, that's an interesting name, isn't it? The Rotten Egg, or the Calabash Nebula. I have a question. Why did the astronomers call this the Rotten Egg Nebula? It looks like a rotten egg. Well, okay, that's one thing. Anybody else? It stinks. Well, how do you know it stinks? Have we ever sent anything into space that can smell?
No, the color by what it's made of.
Oh, the color by what it's made of. So how do we do that? What scientific instrument would we use to help us to decipher, if you will, the color and telling us what that is?
Spectrometer.
There you go, the spectrometer. And so that's what they did. When the astronomers looked at the gas coming out of that star, that nebula here, when they ran it with the spectrometer, it came up with hydrogen sulfide, the rotten egg gas. All right. There's another view of it. Almost looks, if you will, like a big vase, or those in the Northeast, a vase. And we have here, there's the star and the gas that's coming off of it. Okay. Well, let's go. We have, let's see, we have down, and we're going in the next week. Here's, whoops, back up. Notice that Galileo in the same year, and a few days later, he sighted Ganymede, finally the other of the moon of Jupiter. We're going to have a third quarter moon and some other things here. So here's our third quarter moon. Remember, we had a full, and we come around, we're now our third quarter. And let me back up here. I want to point out, here is on Wednesday evening, the 14th. It says at 2 o'clock. We can't see it. That's in daytime. But that evening, if you will go out and look to the west as the sun sets, the Mercury is trailing the sun. So the sun will go down, and in the early twilight be looking up to where the point on the horizon where the sun set, and you'll find two bright objects. Notice that Mercury is just a degree away from Venus. Venus will be the brightest, that's the planet, and then Mercury will be next to it, and that will be the other planet that you can see that evening. So that's one way we could find Mercury. Okay, let's go on. Thursday the 15th. Here we have on the sunset, we're going to have Canis Minor, which is the little dog. Not a whole lot there. We're going to find. We're going to use, as far as our pointer, we have Gemini that's going to be over here to for us to go from. And then for Canis Minor, pretty well the only thing we have is the one star of Procyon, right there. And here is Procyon, and here's Sirius, and here's our Milky Way is going through there. And then over here, look what's right here. Here is Orion, right here. So you can see, by the way, up here, here is the head of Taurus the bull. So you can see those different relationship there. Next, we're going to go on Saturn going into Scorpius, but we have the other constellation of Volans. Volans is the flying fish, if you will.
And we're going to come down, and we have, here is Sirius right up in here, and we're going to come, and here is Volans. Now, in relation, remember we talked about last month Mensa and the large Magellanic Cloud, and so here you have the relationship of Volans to the large Magellanic Cloud right there. Here's the second page, and let's see. Okay, there's no Caldwell objects, there is no Messier objects, there are no bright stars, so we don't have a whole lot in there, but we can see some different things. Here is the Meat Hook Galaxy, and you can see that. Looks like a giant S. There's a little bit more of the core of it. Now let's go to week number 4 as we're going on, and we're going to see the sun is going into Capricornus. We're going to get a new moon, and we have another constellation that day, that evening on Tuesday. So we have gone, we started with the first quarter, we went to then the full moon, third quarter, and now we're at new moon, and it starts on the new moon, starts a new lunation number, so it starts with 1139. And we also have this constellation of the lynx. The lynx right here is named after the cat, a lynx. Very basic. Notice virtually no stars at all that we have in there. We can use again Gemini and Auriga to help us to find it as we look for it a little bit later here. We also have over here Ursa Major, the big bear, and if you know, you see these two stars right here? This is one of 3 sets of the foot pads of the bear. And so when we get the star ball on, we will look for, there's 1, 2, and 3 feet of the bear, 3 of its 4. We'll look for the third, and then lynx is going to be right along here. It'll be in between the foot pad and Gemini. That'll help us to find it. Here it is here. No Caldwell, no Messier, and so no stars, very basic. But there's a few things. The Intergalactic Wanderer, they call it. NGC. And we go on, in the 21st, we have our perigee. Remember we had earlier in the month the apogee, and now we have the perigee. And the way I remember between the two is I always think when I hear the perigee, I think that the moon is perilously closer to Earth. And when I think that, then I know that's the perigee, and then the apo is the farther one for my memory. Let's go on. Here we have now, that's about it. Week 5, we have we go on to our first quarter moon, and then we have our constellation of Cancer the Crab. Here it is here. Again, there's Gemini. Here's Canis Minor. There's Procyon. Leo the Lion is going to be right over here. So we have a lot of helpers, pointers for us. The lynx, the cat, is right up here on this. And so we have, the only thing we're going to have, and it's an interesting little object right there, this cluster. It's a very faint cluster. By the way, the names here of these 2 stars, Acellus Australis and Acellus Borealis. This means northern donkey, southern donkey, and we will see in here what this is, this little cluster. Here it is. Here's the cluster right here. And as you read through here, sometimes it's called the beehive, but also its Latin name is Praesepe. And for those who can read that, can you see what Praesepe means in Latin? Manger. And this is named the manger for Christ's manger in the sky. It's very interesting. And there's where, this is it right here, that yellow circle, if you will. All right, we're about to finish up for our calendar here at Mercury, and as you see, the next month on Saturday the 31st will be from 6:30 to 8. We will be talking about the February sky. And to give you the idea of what it's going to be like through the year, here is the 2015 calendar. And if you notice, the last Saturday of each month is when we will do the presentation, with the exception of the last 3 months, October, November, December. October, we have to bump it up because of Halloween. November, we have to move it because of Thanksgiving. And December, we have to move it because of Christmas. So the first 9 months, it is the last month of the last Saturday of the month, and then the last 3, October, November, December, we have to change it because of the holidays. All right, any questions so far? All right, none. Here's the constellations. Now, as we go through with the star ball, we're going to start up at the north, and we will work our way down to the south. Here are the 8. And in doing that, as we get ready here to turn off the projector and get it real good and dark, I want to point out how you use your eye to see dark, faint stars in the night sky. We have 2 sets of photoreceptors that we can see light with. The cones and the rods. The cones is what we're using right now because they are the only ones sensitive, as it shows there, to color and bright light. And so that's what we use in the daytime, in white light. Now, the rods is what we will use here in a little bit when it gets dark here in the dome. Notice the graph. What happens is when we are in bright light and then all of a sudden we turn off the lights or we go outside and it's dark or something, the light intensity decreases. As it gets down to a certain point for each of us, it will be a different point because of age, health, and how bright was the light that you left, and all sorts of things. There's going to be a region for the switchover point. Our brain is going to pick up that our cones are not picking up any light. So an electrical signal is going to come through our nervous system, through the optic nerve into the back of our eyeball, both of them, and that electrical signal is going to change, if you will, the chemical composition of the fluid that's in our eyeballs. And what that fluid, that vitreous humor, is going to do, it's going to then sensitize our rods. And that's what we will do. Now, in the daytime, we can look and we can see, and we put whatever we're looking at right at the very back of our eyeball on what we call the fovea centralis, the central point of focus. There's where you want it. That's where you get the most precise focus. However, the rods are not there. Now, it'd be great if we changed over that the cones would move out of the way and the rods would move in, but they're all fixed, and so it doesn't change. So here's what we have to do. To see something dark, like a star, what we have to do is we have to concentrate on keeping that star off of that fovea centralis, because that's the only place where the cones are, and the star is not going to be bright enough that we can see it by looking directly at it. So we have to use what we call either averted or peripheral vision. All of us use that as we drive. We were driving on the streets. We're concentrating, I hope, on what's in front of you, but we are aware what's on either side, left and right, of the main part of the street as we're going down. We're watching for vehicles coming in from the side. We're watching for people and all sorts of things. So we're used to our peripheral vision. So what we have to do in the dark sky is you have to remember you want to look away from the star and get it onto your, right here, onto the rods. We would look from the front to the back of our eyeball. The bird would still be on the fovea centralis. We wouldn't see it because it's dark, and we would then be able to see the stars. Okay, we're going to get ready. So let's turn off the PowerPoint projector. Let's bring up the star ball, and we will let our eyes adjust. Here we go. All right, we should have now our first constellation up, and if I remember right, it should be the Lynx. Isn't that correct? All right, the Lynx. Now, let's see if we remember we talked about how we're going to find the Lynx. As your eyes adjust, we're looking toward the north, down in front of us. Do you recognize anything up in front of you in the sky? Can anybody recognize anything up in the sky there? Pardon? You can see the Big Dipper. Okay, here we go. Here is the Big Dipper, what we call. Now the Big Dipper, just to clear that up for you, that would be technically called an asterism, A-S-T-E-R-I-S-M. And an asterism, by definition, that's any object in the sky that has been given a name that is not the name of any one of the 88 constellations in the sky. There is no constellation called the Big Dipper. The Big Dipper is a part of the constellation called Ursa Major, the Big Bear. Now, if you remember when I was talking, we want to find the foot pads of the bear. Do you see them? Should be 3. Okay, let's do this. Look at the dipper. Find the pot. You see the pot? Let's go, and we'll go down from the pot, going south, and we come down and off here. Here is one of the foot pads. We come down and we go way on down. Here's a second foot pad. You see that? Let's go back up to the dipper. Let's go from corner to corner on the dipper as it points, and it's going to point to the third foot pad. Now, where is Lynx in relation to the third foot pad? Going to be in this dark area here. And also what's going to help us, look what's right here. Here is Gemini. Okay, so let's bring up the laser drawing. Okay, Rebecca, if you'll bring up the laser for links. Here we go. Good. Okay, in relation, here is links. There's our footpad. Here's the top of Gemini. And here's our relationship. Can you see where we would be able to find it? So this is links, the furthest north. All right, our next one. Now, what would you think would be our next one?
Yeah, Gemini.
Gemini.
We're working south, right?
Correct. Now, before we go there, and let's leave it like it is right at the moment, right over here, here is what's up tonight. Here is Auriga, the chariot driver. Now, remember me asking you to look for the brightest star in the night sky for us on that night, and it would be here, it should be a little brighter, will be outside. Here is Capella. You see the 3 stars, the little kids? Turn on the stairwell lights, please. You have enough light there? Okay. Yeah. That's right. Okay, you can turn off the stairwell lights. Thank you. All right, let's go back and let's take a look. Here again, here is Auriga. Fred, you need by me? Or you go? Okay. Okay. Here's Capella. We come over, and right here is Minkalainen. Here's Delta. Here's Theta. See how a straight line they are? Measure from Theta to Delta. Right up here. Let Delta be your anchor point. Swing your other tip of your finger, whichever one it is. Come around. It'll come up right about in here. Let this be your anchor point. Now come back to Delta. Swing it. And here is Polaris. Okay? What we said is the angle from Polaris to Delta Aurigae is twice the angle from Delta to Theta Aurigae. So there's another way to help you to find the North Star. All right, so Lynx is right here. Let's go down south a little bit. Let's find, if you will, Gemini. G-E-M. You got it punched in? You got it punched in. Okay. Again, Auriga, Lynx. So where would you say Gemini is going to be? Should be straight ahead. So let's draw it. Put up the laser. There we go. Very good. And here we have Alhena. And here is Castor and Pollux right there. Now, with the laser up, let's look up here, if you will, up to our upper left. Find the Big Dipper. You see it? Again, come back, find the handle to the connecting port of the part of the handle to the pot, and go from that star to the opposite diagonal, and notice it will point to Gemini. See how that works? So there we have it. And as we continue on down, you're going to see something else right there. What's that? That's Orion. So let's go on. Let's see. From Gemini, we need to go now. I believe it's Monoceros, isn't it? Cancer. Okay, Cancer the crab. All right. Now, again, what's this right here? Here is Gemini. Now, Cancer is going to be back to the east, if you will, of Gemini. And notice over here, we'll get in a couple months, we're going to get Leo. Here is Leo. So Cancer is right in between Leo and Gemini, and right here. Now you're going to have to pretty well look away, look off to a side, and when you do, then you should be able to pick up and see better to the cluster of Cancer the crab there, and Praesepe the manger. Let's trace it out. Okay, good. Northern, that would be the northern donkey and the southern donkey. Okay, Leo, Gemini, and we had Cancer. Now we come down, and what is next? Canis Minor. Now, where's going to be that? Let's see how we can find this. Yeah, it's right here. Where's here? Here we go. Okay. Very good. And here is Procyon and the two stars right there. And up above here is Gemini. We come on over, and helping us in the sky is Orion. And we're going to come down to another one in just a little bit as we get on down closer. But there is Procyon. So draw it out. That ought to be pretty easy. There you are. That didn't take long, did it? Okay, what's the next one? Is Monoceros there. And it is, now let's see if we can figure out where it might be. Gemini, Little Dog, Orion, and if I remember right, it should be in between Orion and Little Dog, right? So, should be right in here, so let's draw out the unicorn. There you go. Okay? Now, next one is going to be the big dog. Now, let's go back up and come up. Here is Gemini, Little Dog, and then we had right in here was the unicorn. Now we're going to come down and let's see how we would use Orion right here, the ultimate, if you will, pointer. Look at the belt. See the belt there? At an angle, what is it pointing to? The brightest star in the night sky? Sirius. Very good. Let's trace out the dog. Now, here he comes. Good. Very good. Now, we said that Sirius is the brightest star in the night sky. How far away is it? 9 light years. We come on back down in here, the different one. Here is Aludra down here, the tip of the tail, and what about it? It's the farthest of all the 100 brightest stars. It's about 3,200 light years away. Now you can turn off the laser and let's take a look. There's your constellation. There it is. Okay. Now, one of the things we can do, we can use the backbone of the dog. Put the laser back up. And we can go up, if you will, and what's up in here? What's the dog, if you want to say he's pointing at? He's pointing at the unicorn, the Monoceros. But if we go back down the other way, what are we going to find? The pupus. Now, okay, turn off that light. Yeah, very good. Okay, here is the big dog, backbone, and what are we going to look for? Where are we going? Right in here for pupus, the stern or keel. Well, yeah, that too. Yeah, the stern, the back end of the dog. Okay, let's trace it out. Here we come. Good. Now, using the dog helps us to find two of the fainter constellations, Monoceros and then also Pupus right here. Okay, question on that. Again, we still have Orion to help us as we keep navigating down through there. Yes, ma'am. Yes, we can. Okay, there's the last one we cannot see when we get to that one. Okay, after Volans, after Pupus is what's our next one? Volans. Then we're going to get, and you notice how much further south we went. We're not going to be able to see that. So let's see, we got Pupus back up here. Here is our dog, Pupus, and we come down. Also, we want to come off of Orion through Lepus the rabbit, Columba the dove, and we should come down. And by the way, do you see what looks like a smudge on the dome? What is that? The large Magellanic Cloud. Very good. So the small should be right about here, isn't it? Isn't that it? Right down here? Okay. And where is Volans in relation to the large? Right in here. So let's draw it out. Here we go. That's the flying, the flying fish. And or a bat, you can call it whatever you want. But our southern horizon would be somewhere right up in here. To give you a perspective, look over here to the left. Anybody recognize this part of the sky? Pardon? The Southern Cross. And we have the Southern Cross. We can see on where we are up here in Texas, we can see the top two of these stars, the cross right here, Alpha and Beta, right there, those two. Our horizon line would go right along here, and it's going to go just above Alpha and Beta Centauri, right down here. This is the closest star to us after the sun, the next, and then we have, we come on to Capella, like we talked about in Arc. Okay? I think, let's see, 1, 2, 3, that should be it, isn't it? Okay. Any questions? We're going to go back up to the north, but anybody have any questions prior to we start going? None? Let's go. Okay, Volans. Let's look at the laser. Review. Okay. Magellanic Clouds. Okay, let's go. What's the next constellation we're going to look at? Pupus. Okay. Where is it? Right there. Okay. Good. What's next? Canis Major. Big dog. Comes out as a very good pointer for us. There he is. What's next? Monoceros. And here he comes, Monoceros, right there, pointing for us. Good. What's next? The little dog. Right there. Now, hold on. Go ahead and turn that off. Stay right here. When I learned my stars at nav school, we went from Capella, Castor, Pollux, Procyon, Sirius. We called this the Arc of Capella. Now, if you continue with this, you will come up with the 5 major stars for the winter hexagon. Let's see, 5 would be, no, pentagon. Anyway, Capella, Castor, Pollux, Procyon, Sirius, Rigel, Aldebaran. Can you see? And those are, you have here concentrated some excellent constellations to give you good pointer systems. Here is Taurus the Bull. Here is Orion. And then we have Auriga the Chariot Driver. We have Gemini Twins. We have the Little Dog. We come on down, and then we have the Big Dog. So you can learn a significant portion of the night sky. Okay, let's go. Let's see, we were on Monoceros here, so what's our next one? Okay, Cancer, and that should be in the region right here, and relationship, here is Leo the Lion, here is Gemini the Twins, and in between. Okay, and then we go to right here, Gemini. Here they are. Okay, and let's see what else. Then Gemini. Then the last one is the Lynx. And we go to the dark area. Here it is. Relationship. Auriga the Chariot Driver. Big Dipper. 3 foot pads of the Bear. The diagonal of the pot pointing through the foot pad to the dark area for Lynx, on down to Gemini, and over here in Auriga. Any questions? Those are your major constellations for us for January. And you saw the calendar, so we'll be looking forward to seeing you on the last Saturday night of January as we look at the February constellations. Thank you for coming. Thank you for listening. And a Merry Christmas and a Happy New Year. Make sure it's off.